All right, grab your detective hats, because today we're cracking a cosmic cold case. We're talking about a mystery that's billions of years old that happened long before our own planet even existed. Let's get right into it. So, think about it for a second. How on earth do you investigate a star that exploded and vanished billions of years ago? I mean, you can't exactly travel back in time, and the crime scene, well, the crime scene is basically all of interstellar space. Well, the answer is actually pretty amazing. You look at its fingerprints, you look at the dust it left behind. These tiny, microscopic grains are the only witnesses to that star's fiery end, and they carry its secrets across the galaxy. So, our investigation starts in a pretty unexpected place, inside ancient meteorites that have fallen to Earth. See, these rocks are full of what scientists call presolar grains, and that is literal stardust. And inside that dust, there's one particular type of grain that holds a really strange secret. And this is it. This is our person of interest, the presolar graphite spheral. It's this tiny, tiny little ball of carbon, smaller than a human hair, that was forged in the wild atmosphere of a dying star. These things are basically microscopic time capsules, and this one has a clue inside that's been stumping scientists for years. So here's the puzzle. The grain has this weird structure. Its outer shell, the rim, is made of these really well-understood layers of graphite, kind of like a tiny onion. Totally normal. But the core is a complete enigma. It's this bizarre nanocrystalline stuff that we just can't make on Earth. That is our mystery. What is that stuff? To solve this, a regular magnifying glass isn't gonna cut it. Nope. We need to bring in the heavy-duty equipment. We need an atomic scale forensics kit, using microscopes so powerful they can see the unseeable. And our number one tool for the job is the electron microscope. Now, instead of light, this thing shoots a beam of electrons at the sample. And because electrons can see things way, way smaller than light can, we can get a picture of how the individual atoms are arranged. This is how we're going to gather our evidence. The whole process is incredibly delicate. First, scientists have to find and isolate just one of these microscopic grains from a piece of meteorite. Then, they put that tiny grain under the electron beam. And finally, they analyze the patterns that come out, the atomic fingerprints that will hopefully tell us what this stuff really is. Okay, so the forensics team gets to work, and the clues they start pulling from the heart of this stardust, well, they're strange. And honestly, with each clue, the mystery just gets deeper and deeper. The very first clue is what's not there. It's a missing fingerprint. The test shows signs of graphene. You know, the basic sheets that make up graphite. But the main signal, the peak that tells you those sheets are stacked up neatly, it's just gone. Completely absent. Even messy carbon has it. This is a huge deal. It means the core must be made of totally jumbled, unlayered sheets. Then there's clue number 2. The shape is all wrong. Normally, carbon sheets like to form nice, stable hexagons, kind of like a honeycomb. It's just more energy efficient. But here, the sheets were sharp, spiky, and triangular. A shape like that is super unstable, and it points to some kind of really bizarre, really rapid growth. Clue number 3 is a simple number. By measuring its density, the scientists found that the core is actually way lighter than its own shell. It's less than 90% as dense. So right away, you know, the atoms inside aren't packed together neatly. It has to be some kind of porous, chaotic mess, which pretty much rules out any slow, orderly formation. And our last clue, well, it's like finding something frozen in time. Using a special technique that makes heavy atoms glow, they saw that elements heavier than carbon were just scattered randomly all through the core. They weren't clumped together, which they would be if they had any time to move around. So whatever created this core, it happened fast. Okay, let's recap the evidence. We've got unlayered sheets, weird triangular shapes, low density, and atoms frozen in place. Now, it's time to line up the usual suspects. The scientific theories for how this crazy material could have possibly formed. So how do our theories stack up? Well, suspect number 1, a slow atom-by-atom growth, that's out. It would have created neat layers. Suspect 2, the idea that big molecules just clump together,
that doesn't work either. You'd get smooth, relaxed shapes, not these sharp triangles. But then you get to suspect 3, a theory called dendritic melt, and suddenly it all fits. It explains the missing layers, the triangles, the low density, and the frozen atoms. Check, 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 and check.
So you follow the evidence, and it all points to one single, kind of mind-blowing conclusion. The core of this ancient stardust, it's made of frozen liquid carbon. The key, just like the research says, isn't how it was built, but what it was built from. See, instead of starting with single atoms floating around in a gas, this theory says it all started as a droplet of liquid carbon. And that, well, that changes absolutely everything.
So there you have it, the solution to our mystery. The core didn't grow slowly over time. It was born in an instant. It's a tiny droplet of liquid carbon probably blasted out from a violent stellar storm that flash froze in the cold of space.
And this is the only theory that explains everything. The super fast freezing is why there are no neat layers. The weird branching dendritic growth is what creates those faceted triangular sheets. It perfectly explains the low density, and it explains why those heavy atoms are trapped right where they are. It all just clicks. Case closed. I mean, that's just an incredible story, isn't it? We solved a mystery that's billions of years old just by looking at the atomic structure of a single speck of dust. It really makes you wonder, what other cosmic secrets, what other amazing stories of how stars are born and die are just hiding, waiting to be discovered in the very next grain of dust we find?